Okay, now we're going to look at y. Instead of looking at what x might equal, now we're going to look at what y might equal. Okay, so y is greater than 2. So I need to look at where y is equal to 2, and that's going to be right here. Y equals 2 right here. Well, where else does y equal 2? Y equals 2 right here. Y equals 2 right here and here. Y equals 2 all the way across here. Y equals 2 all the way across here. Okay, so that's with x equals something, that's a vertical line. This is y equals a number, so it's going to be a horizontal line. So I'm just going to put in a horizontal line in here. Now, will this be solid or dashed? Well, it's not also or equal to, so this is going to be a dashed line through y equals 2. Okay, all right, so there's what that one looks like. Okay, and it says y is greater than 2. Well, where are the y values bigger? The y values aren't bigger left, right. The y values are bigger up, down. So what number's bigger than 2? 3. So all the y values that are bigger are going to be above this red line. They're going to be above this red line. All right. Let's add in another line. This one is y is less than or equal to 6. Again, you go to the y-axis, put a dot right there, and you ask yourself, is this solid or dashed? Well, it's also equal to or equal to, so this is going to be a solid line straight across there. This is going to be a solid line straight across there. Okay, now, so the ones that are less than 6 are going to be below. The ones that are less than 6 are going to be below. The ones that are greater than 2 are going to be above. So as you can see, you would shade everything in between there. So that one's going to look like this. That's the solution to the system of linear inequalities. Y is greater than 2, y is less than or equal to 6. Okay, so you've noticed that if they're both vertical, yes, it's going to be everything between them. And if they're both horizontal, yes, it's going to be everything between them. But you can't just say you always go between the lines, because you might end up with something that's not two parallel lines. All right, so let's look at another example. Now we have an x and a y. So let's do our x first. We need to go to the x-axis for that one. Have to go to the x-axis for this one. So you go to where x is equal to 2. All right, now where else does x equal 2? All the way up above it, all the way down below it. And is that going to be a solid or a dashed line? That is going to be a dashed line because it's not also or equal to. Cannot equal that. Okay, there's that one. Now let's look at the y is less than or equal to 5. Now we're looking at the y-axis, not the x-axis. We go to where y is equal to 5. It's going to be solid or dashed. Well, that one's going to be solid because there is an or equal to. So I need to put a solid line straight across there. Okay, so let's see what that one looks like. Yep, there's my x is 2, and it's dashed. There's my y is 5, and it's solid. Okay, now I need to think about where is the shading going to be. So on the x, it's left, right. It's not up, down. It's left, right. So where are the numbers bigger than 2? They are to the right. See, they are to the right of the red line. Now, where are the numbers less than 5? They are below the blue line. They are below the blue line. So where is both of those true? Both of those are true right in here. That's where both of those are true. Okay. So this is what that solution looks like. All right.